Today we are going to study about percentage resistance, percentage reactance, and impedance of a transformer. So basically, why we study usually percentage resistance and percentage reactance and impedance are used to study because they give copper losses and various other values which are required and which are very important for us. Now, how to calculate percentage resistance, reactance, and impedance of a transformer. They are usually measured at full load current. Means you all know that percentage is calculated only when percentage is something out of total, means it is a normal part and normal part out of a total part. So what is that normal part and what is that total part? So expressed as a percentage of the normal voltage. Normal voltage can be anything like voltage dropped at a resistance or inductance, or resistance at, like here we have taken resistance as referred equivalent resistance referred to primary winding, or here we have since we are studying resistance, and if we take the case of reactance, so equivalent resistance reactance referred to primary winding. So we'll study step by step percentage resistance at full load, percentage resistance at full load, percentage reactance at full load, and similarly impedance at full load of a transformer. So what is percentage reactance? Percentage reactance is percentage drop, means voltage drop at resistance, equivalent resistance referred to primary winding. We can either take primary winding or secondary winding, but in full case of our study we will be taking primary primary winding. And total resistance supplied by input into 100, something we multiply by in 100 to get percentage. Now if we multiply I1 in numerator and denominator, so we'll get copper loss, we'll get power drop, and here we get power supplied into 100. So this will give the percentage of copper loss at full load. Now since the ratio is same, so percentage R here and percentage Cu both are equal, and both are equal, which is denoted by VR, means they are ratios, so ratios are always equal. Now we'll study about percentage reactance at full load. So what is percentage reactance? Means voltage drop at equivalent reactance referred to primary winding, and total voltage supplied in by the input into 100. Similarly, we have percentage reactance of referred to secondary windings, and total output gained into 100 denoted by common ratio Vx. Now we will study about percentage impedance at full load. What is percentage impedance? Percentage impedance is total equivalent impedance referred to primary winding, or either we can take secondary winding here, and out of total voltage, and here with total voltage. So these are the respective percentage impedance at full load. Now we all know that if we consider a case without percentage also, so we have z is denoted z denotes impedance. Impedance is what? Z square is equals to, we have the relation, you know, all r square plus x square. So we have percentage. Similarly, we can take the help hint with this formula, that percentage z is equals to under root of whole root of plus r percentage r square plus percentage x square. The percentage r square is percentage resistance that we have studied earlier. Now we percentage reactance and percentage impedance and percentage impedance have the same value, whether referred to at percentage primary winding or secondary winding. Now you all may think why they have same values when referred to primary, because they are the ratios. If we take the example of resistance, so resistance referred to primary winding is what? Yeah, consider here the example. What we are finding? R01 is percentage R we can also refer to as VR, or copper loss. So percentage R, if we find R01, so R01 is what? Percentage R multiplied by V1 and divided by I1 divided by 100. So same relation we have derived here. So the relation can be derived, and plus R1, percentage R1 we can put percentage Cu in loss in place, and percentage copper loss is common in whether in considered the case of percentage resist, whether consider the case of copper loss or resistance loss. So that's why this is the ratio which is inclusive of all the values, means it includes the ratio. So that's why here there is no any mention parameter of primary winding and secondary winding, so it is independent of primary winding or secondary winding. Thank you.